Well, it must be Peavey week in the shop because we're going to work on yet another one. This is an old school Peavey Butcher. Kind of excited that this one came across the bench because I've always been really curious about these and have never seen the inside of one or really ever even heard one. Let's just start pulling it apart and see what's going on with it. Alright, this one doesn't have a back plate. Alright, and as with most Peaveys, if you look down here, the bolts that hold in the chassis go right through the feet. Aha! So this Peavey Ultra actually has another set of screws or bolts on the top side here. So I just missed these. Jesus Christ. The fucking head box weighs more than the amp does. Alright, first thing we're going to do here is check the fuses. I can see right away that it looks like one is blown. Same for if it's blown or if it's good. Don't ever let that be your judge. Take your meter and test it for continuity. And yep, that one is bad. So let's go ahead and just pop this out. Let's see what the value is. It's a 1 amp fuse. Luckily, it's written right there on the chassis. Now sometimes on these amps, or any amp really, if it calls for a slow blow, it probably needs one. Now the slow blow means it's not as sensitive to like a spike. I know there's amps like the Laney GH100L, for example. There's a fast acting fuse will pop when you turn them on, just because of inrush current and things like that. Take a look around the back. It's got the mains fuse back here, which is 5 amps. Let's check the other ones before we pop those out. That's the only one that popped. Alright, it's also got these 1/4 amp fuses here. An 8 amp fuse, wow. Now before we go ahead and just turn this thing back on, you really want to figure out why that fuse blew in the first place. So I'm going to take a moment and pull the schematics up and see what else is in line with that and what that's there to protect. Alright, well I've looked over this thing pretty good so far and I don't see anything visibly wrong with it. Yeah, so you've got a whole row of electrolytic capacitors here. The dielectric compound in them doesn't last forever, and when they do dry out, you know, they just go bad. They don't block the DC like they're supposed to, or they could leak certain amounts of AC or whatever. And there's also a bunch of electrolytics underneath this board as well. I'm going to go ahead and try the amp without it. I'm going to just power it up slowly and see what happens. I replaced the fuse and I replaced the output tubes with a set that I know is good. This is what we pulled out. A couple of 6L6 GC tubes. These look fairly old, so we're just going to assume that they're no good and go with a known set before we diagnose any further issues. There is a little oxidation around this output jack here, so I'm going to go ahead and clean that with some deoxit. I can even see the inside of the jack looks fine, but we're going to make sure that that's clean so we have a proper connection on all these jacks. And usually what you can do to clean this up, maybe you just spray like the end of a cable or something like that. A wire brush is better, but you know, not a lot of us have super small wire brushes laying around. Just jam it in there a couple times. What that does is that just kind of eliminates surface grime. There is some electronic cleaner that you can buy at auto parts stores and things like that, but it's a little more harsh and it will damage finish, especially plastic parts and things like that. So I don't recommend it unless you have the proper things to block sensitive pieces or sensitive trim. Like it'll take the ink right off the labels and things like that on certain amps. So don't necessarily recommend that. Deoxit though is pretty safe. I've got a very odd jack system set up back here. Just looking at it, it's got these odd switching jacks. They have 4 output jacks, like you're gonna run 4 16 ohm cabinets off of this thing. If this were mine, I would do away with that. I would do away with all these. That's garbage. I would just put in, I mean, shoot, you drill one more hole in the back of this thing and you can have your dedicated single 16 ohm outlet, or your 16 ohm jack, and 2 8s and 2 4s like it should have. Or you could drill one more hole and just have a rotary switch to, if you really want to drive 4 fucking 16 ohm cabinets, you can, but I wouldn't recommend that either. Cord is damaged too. This could have something to do with it, just for fun. I'm gonna check the continuity of the cable. Yeah, see, that's not a good sign. Doesn't seem like we have a great ground connection there. This cable line needs to be replaced. Alright, so we're plugged in. We got our ground on. And we have a power light. So if you have a problem with the HT section of any amplifier, it's not going to blow that fuse until you flip the standby switch. I got a green light. My fuses appear to be holding, and I've got an open-ended cable in my hand. Let's turn some volume up. Alright, well, I got some noise. Go ahead and plug a guitar into it and see what it sounds like. I think that's all that our problem was just another set of bad tubes. Went through the Peavey Butcher inside and out. Didn't see anything major wrong with it. The tubes, we had a problem with the tubes shorting out and blowing the HT fuse. The electrolytic capacitors are also of the age where they need to come out, or we're going to have bigger problems later down the line. I want this amp to leave the shop rock solid and be able to go out on tour without having any problems. Down here on this end of the board, we got a 100K resistor here, but the schematics show being 1 watt. I don't know if this is 1 watt or not, but it's not even mounted. It's not even mounted through the circuit board. So this is probably going to replace at some point in time. So we are going to mount this correctly and replace the value with the correct part if necessary. Some guys like to tell you about the horror of messing up the traces on a circuit board. Now, while I've damaged plenty of circuit board traces in my time, I don't think it's an excuse to just leave these little nubs sticking up and putting the components on those. You need to just have yourself the correct tools to do the job. A desoldering vacuum works wonders. That way I can do a fresh, clean job. I don't have to worry about pulling any traces up. I mean, that came out pretty simple. I guess when guys are trying to use soldering irons or those little spring vacuum pumps, those little click tools, it's probably why they're burning traces up. This tool is invaluable. I'm going to take these tubes out before I keep knocking them around. Homie's got 2 Tungsram ECC 83s made in Hungary. This one just looks like a gold pin JJ. Personally, I don't really care about new production versus old production tubes. I'm not going to pay any more to get some old Wing Cs, even though they're my favorite tubes. I just think you should put in whatever works and whatever is readily available. The tone, to me, is not that different. It really lies in the circuitry of the amplifier, not the individual components. But it's whatever makes you happy, whatever makes you play better. Dude could probably sell those two tubes and make a little bit of money. Well, I did a bunch of research and I could not find the specific manufacturer for that 100K part. I did cross-reference it with some of the stock I already had, and I do have some 1-watt resistors by Vishay Dale that appear to, for all intents and purposes, appear the exact same. So I don't have another one to replace it with, so we're just going to roll with that for right now. But I think it's going to be fine. Cool, now we drop all our components in. Got all the leads bent up right. Got some nice F&T capacitors here. I don't have any hot glue standing by, so I'm just going to go ahead and put a small dab of liquid electrical tape down for each component, and that should hold it down fine. Awesome. So we've got our preamp tube board done. I'm going to wait until this dries before I spray any deoxit in here. I am going to retension all of these sockets basically by putting like a small dental tool in there and just bending these little pins in a little bit more. And I'll spray it with some deoxit to improve the contact there. So as you can see, they just globbed like hot glue or whatever all over it. And we've just got a dab of liquid E-tape right underneath of it, so that should be fine. So now we're going to have to get to this power distribution board, or the power board, and we'll just have to pop loose all of these quick connects. The schematic for this amp is very, very helpful because not only does it show you how it works electronically, but it also shows you the component layout as well, which is invaluable. It just saves a lot of time trying to troubleshoot these things. Take a picture of the orientation of all the parts. Take more than you need. Take pictures from different angles so you can, if you don't remember where these things go, you just look back at your photo library and it makes that part easier. So there's nothing worse than getting it all back together and trying to go back behind yourself for something stupid. Cool. So with all those pieces out, it looks like we can lift this and wow, we might be able to lift this entire board. That's awesome. Wow, so not only is the Peavey Butcher my favorite sounding Peavey so far, but it is, I'm having a really good time working on this thing. It's just not as frustrating as the other ones. I like the build so much better. Look at that. That is awesome. The whole board just comes out. No desoldering. Well, I mean, we're going to have to desolder components now. But, shit, that makes it easy. Cool. Well. Yeah, the only thing with the desoldering gun is, as awesome as they are, you're going to have to buy a whole lot of tips. Because, I don't know, I kind of use mine to pry on a bunch of stuff, which I probably shouldn't do, but that shortens the lifespan of them for sure. As I was getting the components prepped for the power board, I noticed there was no way to adjust the bias on this amplifier. Now normally that doesn't really bother me on amps like 5150s and things like that. I feel like that's the way they were designed, and I just leave it at that. They sound okay, although sometimes it is helpful to get rid of crossover distortion. So you've probably heard me say before where I don't go against the manufacturer's specifications, but in this case, I feel like for a lower gain amp, you really need to get rid of that crossover distortion, because I think you're going to hear it, especially if you're playing on lower gain tones. I've actually figured out a way. Yeah, I can mount a small potentiometer to the side of this board, because one of the things that's great about these boards is that this whole thing, you can solder to this entire pad. It's not just a regular trace that's underneath, you know, any type of laminate or something. So I think if I drill one hole for one leg of this potentiometer right there, and then I replace this component here, R53, which is a 470K, no, that's a 47K resistor. I'm going to put a 10K in series with this potentiometer here. And I'm also going to replace this one, R52, which is a 470 ohm resistor. I'm going to replace that with, I don't know, maybe about 1K, maybe 3K. If we don't get within the correct range when we try to bias this thing up, we're going to have to pull this board and try a different pair of components. I think this should get it pretty close. See how neat we can do this. Sorry you missed me drilling the hole, but I just drilled a very small hole right there on the edge of that board. If you flip it over, you can see that I can connect. I can just solder both of these tabs directly to this big ass pad here. Now we're not going to be putting too much force on that, but I think that's a pretty clean look right there. Just stuck right on the side, so when this is all set and mounted, you'll still have to take the amp open to adjust the bias and everything, but that's out of the way. It's easy enough to pull. If you look at it, the hole that we drilled was right beside this on the edge, so if you pull this thing out and put all the stock values back in, you can reverse this mod super easy. Alright, now I want to show that off one more time here. Let's see, will this thing focus in on it? I don't know, I can't tell. But that's rock solid. All those pieces are there, that's in there firmly. It doesn't have any movement to it. There's too many times I see bias mods on 5150s and JSXs and, you know, even dual bias mods for some Marshall amps, and they're just so sloppy and the components are flopping all around, and you're drilling holes in the back of the chassis and everything. I mean, the drilling hole part is fine if you want to ruin something that's classic. Go right ahead. You know, I do it to a lot of my amps that I'm going to tour with. Drill holes all over them because that's what I used them for. I didn't buy them to look at. I bought them as workhorses. I'm very, very happy with the way that turned out. Easily reversible. Now we've got something we can definitely work with here. Great. Well, let's populate the rest of the capacitors on this board. We still need to replace that 470 ohm resistor there. Let's not forget about that. When I was looking at this bias circuit, I noticed I didn't have one of the right values in my pile of parts here. That's why it's always good to double check. Take pictures of what you're working on, write down the values of what's in there, and cross-reference them with the schematics that you have. And actually, it'll never focus on it this much, but if you look on the schematics, you can find a PDF online or something. The value of C28 as showed on the circuit board layout is 100 UF. That is not what was in there, and when you look at the actual electronic schematic, it says C28 is 1000 UF. So that can be a pretty big boo-boo if you don't catch that. Always double check everything. Well, there you go. We have a finished power distribution board. For some reason, I was not able to get a axial one. I was just able to get a radial 1000 UF capacitor. So, but that's all right. I already double checked the height on this, and that is going to work. So if you did have to get taller ones, I got one component down here that's not going to play nice. So I do have one more 100 UF capacitor down here that it looks like if I have to take that off, so yeah, this board is actually held on by the tube sockets themselves, and those are riveted into the chassis. So in order, if we were to flip this to change this component out, then I'd have to drill out each and every one of those rivets, and I think that's a little extreme. So it looks like we can actually solder this component from the top of the board, which is good. Now if I couldn't do this, then the other way to do it was to leave these legs, and you can wrap a loop with the legs from the new component around the existing ones and put a solder joint on that. I don't like to do that. I mean, sometimes it might be the only option you have, since the Peavey layout that they give you in the PDF actually pretty much details very well how this board is laid out. I know there's nothing hidden over there that's gonna mess me up, but you do have to make sure your leads are short enough that they're not going to hit anything else on the way down. All of our electrolytic capacitors are in. We can go ahead and double check, make sure we didn't miss any solder joints or anything. All right, we're getting pretty close to putting this thing back together. Another thing I really want to do is retension all of the tube sockets here. And I've had a couple. I used to never do this until I put back together a few amplifiers where they didn't quite work right, and lo and behold, you're chasing your own tail to just end up coming back to a simple socket problem. So to retension these, you can really just take if you have like a super small flathead screwdriver, or even a dental tool works. You don't want to be super violent with this. You just want to gently kind of work it in there and see if you can squeeze that piece of metal shut again, or just bend it. I'm just trying to put a little bit of tension on it. I'm not trying to go crazy. Now to clean them, we can just spray a little deoxit right in them. Maybe spray it on the pins of an old tube. And just wiggle it in and out of there. That's pretty much it. And of course, as soon as I almost finished putting it back together, I end up finding the correct piece here. The value of the other one I had in there was correct. It just was a radial and not an axial type capacitor. It would have still worked, but for consistency's sake, I wanted it to match what was in there. I'm also very interested to see how the bias is going to look. So I've got the amp put back together and pretty much ready to put the new tubes in and fire it up. But there's one more thing I want to do. This amp is going back to a friend of mine, and I really want to make sure that if he goes out on the road, this thing is easy to work on and it's not confusing. And one thing that I never quite understood with this Peavey Butcher is the output jack section. One, this had a little bit of oxidation on it, but the way it's wired is if you were going to use 4 16 ohm speakers, it's a series of switching jacks. I guess if you're going to use a single speaker, you would use your 16, your 8, your 4, but it doesn't exactly, it's not intuitive to say I want to use 2 8 ohm speakers. Which one do you pick? So we are going to hardwire some different configurations in here. So how we're going to make this a little bit more intuitive here is I'm going to take this 4th jack here and replace it with a switch. Then I'm going to put 2 jacks here, and another jack here. I'm going to put a white one there, so this will be your 16 ohm only, and then these two jacks will be switchable by the switch. This will be more like a modern amplifier after that. Alright, if we look at the schematic here, we'll be able to easily tell which one is 16, 8, and 4. And it looks like very similar to a Marshall. The negative feedback wire is, it's this little blue wire in here, and that's attached to the 8 ohm tap. Your orange, 16, white is 8, green is 4, and black would be the end of your coil.
Hi Daddy, how you doing?
Hey sweetheart, how are you doing?
Clean up the garage?
Mama helped me last night, yeah.
Wait, are you doing a video right now?
I am.
Is this on YouTube?
It's gonna be on YouTube. Alright, we're gonna change the cord out for him too. All right. Now for this, we're going to use some electro-harmonics. I've got a couple different sets of these, so if we can't get these within the range we want, I can actually try to just swap a different pair out or a different quad out and see if that does any better. I've powered everything on, I've put the new tubes in. I've got each of my probes hooked up to a separate multimeter over here. Don't really have a good shot for you to see the numbers, but right now both of them are reading at about 42 milliamps, 43. Pretty damn close. I've powered up slowly with a variac just to make sure that the caps don't get hit with too much inrush current or whatever. I've got a third multimeter here so I can get the plate voltage. Let's see what we come up with. 482 on one side, 487. So my plate voltage is right around between 480 and 490. We're just going to say 487. If I go ahead and do the math, the plate dissipation of your tube divided by the plate voltage, you do 70% of that, you're going to wind up with about 43 milliamps of current. And right now, I'm idling. I've got about 49 on one side, 47 on the other. That's still pretty close. Let's see if we can bring it down a little bit. So that's actually hotter than I expected it to be. So I've got one side at about 43, the other side at 45. I think that's suitable enough that we should plug a guitar into it and see what it sounds like. Well, I'm very happy with that. Very happy with the way that turned out. The adjustable bias worked out great. We fell right within the right range, right off the top, almost. You know, we can even go ahead and check our... We can go ahead and check our plate voltage again. We're sitting real good. 485, maybe 490, whatever. That's not going to change our number, though. Alright, well, let's box it up and put a microphone in front of it and really check out how it sounds. Alright, so I've got the Butcher here all fired up and ready to rock. I've got it running through a cabinet with vintage 30s in the bottom and another one with G12 T75s. And I adjusted the hum balance control in the back because when I turned it on, it was humming a little bit, but nothing extreme. But just a few turns, I just used a pick in there to adjust it, and it's quiet as a mouse. This thing is awesome. I mean, and there's no buzz, there's no hum. That's great for an amp like this. And right now I've got an SM57 on a G12 T75. We're going to move that over to a vintage 30. I'm really curious as to hear it out of both speakers. Here's just what it sounds like raw. I've just got a Dean guitar plugged into it. I've got Gibson pickups in this one. This is just a 498T in the bridge. Preamp gain on the Butcher all the way up. Mids on 10. High and bass on 5. I got the presence on 0 right now. And the post gain, which is basically the master volume, I've got that on 3. Just hear it like that. The 6L6s in the power section are really what sets it apart from its Marshall counterpart. I mean, that's really what it was based off of. You'll see that in old Laney AORs, even the Laney GH100L. They're still very, very close to a Marshall 2203 or 2204. But if we itch the presence on this up, let's just throw it up to about 6. It makes a big difference. Now I have to tell you, on all my Marshall amps, I don't roll the presence up at all. This is probably one of the first amps ever that I've been like super stoked about having it up. You know, I never turn them up, ever. This is the best Peavey I've ever heard in my life. The Peavey Butcher. I think they only made them for like 2 years, like 84, 85, 86. Just listen to that, man. All right, well, that's enough of the G12 T75. Let's move it over to the Vintage 30. Turn the presence back down and see what happens. You just get way more of an aggressive sound. I'm not even going to mess with the EQ because if you're familiar with single channel Marshalls, it's inherently the same thing. The EQs are coming off of a cathode follower, which means they are only subtractive. They don't add anything. Man, this is an awesome amp. I really wish I had a tube screamer here to just put it in front and we can really hear this thing fucking rock. But that's an awesome tone. That really is. I mean, this is very reminiscent of a JCM 800, my favorite amp of all time. And I have to say, after hearing this one, I'm going to be looking for one. This one's going to go back to its owner. I'm going to put a still right now of what the back looks like now that I've changed up the impedance selector. So hopefully that should make a little bit more sense. Other than that, no modifications except for the bias mod, which I'll put exactly what I did in the description. For shits and giggles, let's turn on a metal zone. Well, I'm going to sit here and play this thing for a couple more hours because it's fucking awesome. Thanks for watching. If you got one of these, please sell it to me because I really don't want to have to give this one back. Anyway, tune in next time and we'll see you later.